Hi there. Today we will be going over how to configure Drexelbrook's Impulse TDR transmitter using HRTWin. HRTWin is Drexelbrook's proprietary software that is used across most of our HART-compatible products for calibration, configuration, and troubleshooting. The software is available as a free download from Drexelbrook.com and is compatible with Windows XP and above. So let's get started. We currently have an Impulse transmitter currently hooked up to our computer using a HART modem. Although there is a version of the Impulse TDR that supports Modbus communication, this tutorial applies only to the HART-capable 4-20 version. The first step is to open HRTWin. The first thing you'll want to do is select the proper COM port. If you do not know what COM port your modem is on, you'll need to go into your computer's device manager, find your HART modem under the ports section, and find your corresponding COM port. Or you can have HRTWin search automatically for the ports, which is what I'll do. Hit search ports and hit OK. Once you hit OK, it may take a few seconds for HRTWin to load the configuration for your device. Let's start by going over the buttons at across the top of the menu. Read Transmitter reads all the pertinent data from the transmitter and displays it on the screen. Write to Transmitter sends new or edited configuration data to the transmitter. Data fields that have been edited but not sent to the transmitter are displayed in red. Real-time View will show you the real-time output that your transmitter is currently showing. Next up, we have tank mapping. Tank mapping allows a vessel profile to be obtained by recording non-level reflections above the actual level. This recorded profile is subtracted from the live reading, which helps in eliminating fixed reflections from the measurement. In other words, this function is used to erase false reflections that may be caused by ladders, agitators, baffles, and other obstructions that may be inside of the tank that you don't want the unit to see as level. Next, we have D/A trim. D/A trim allows a field reference meter to be connected to the transmitter for adjusting your transmitter current output. For example, after calibration, you observe that the tank is empty and a handheld current meter reads 3.94 milliamps, while the real-time view on the PC menu shows 4 milliamps. By adjusting the D/A trim, you may digitally manipulate the output current to equal 4 milliamps. You may also wish to do this on the high end to adjust your 20 milliamp setting. Next is TDR configuration. This function allows you to select the fault current for if and when the unit goes into either a lost echo or a near zone error condition. So for near zone and lost echo, you have drop downs whether you'd like the current to go high or low for each of these options. Lastly, you have view signals. This function allows you to view and record the live waveform signals coming from the TDR. This can be very helpful when troubleshooting erroneous signals in the field. To configure the Impulse TDR, the following parameters must be known. 1. Your tank height. Secondly, your LRV, or in other words, your lower range value. Next, your URV, or your upper range value. Next, you also want to know whether the material you're measuring is conductive or insulating. On the Impulse, we have 3 different settings. Oil to represent insulating fluids, water to represent conductive fluids, and custom for special applications. You'll also need to know your probe length. The probe length is measured from the bottom of the mounting, or bottom of the threads, or bottom of a flange, to the tip of the probe. Also, you'll need to know what type of probe you have, whether it's a single cable, twin cable, single rod, twin rod, or coaxial style rod. As you update these settings, the image here will update along with it. So let's go through some of these settings. Level, units, I will leave in inches. My tank height, I'll make 26 inches, just as an example. My LRV, I will leave at 0 inches. My upper range value, I will leave at 24 inches. Now, I'm going to be measuring something conductive, let's say, so I'm going to switch this to water. Notice how we have a value for signal area and threshold. These are two parameters that the Impulse TDR looks at to qualify a waveform signal as a level signal. If we change it to water, once we write to the transmitter, you'll notice that these values will also change. Tdr cable offset and signal selection, I'm not going to touch. I would recommend leaving this alone. Going down here, you have upper dead zone and lower dead zone. Dead zones on a TDR are known as areas of non-measurability. These values are defaulted and vary based on whether you're measuring something insulating or conductive, and also vary on your probe type. I'm going to leave these values alone. My probe length. The unit that I currently have hooked up to this computer is 24 inches long. Also, I have a coaxial style probe, so I'm going to switch to coaxial. Once I have everything filled out the way I'd like, notice that the blocks are in red. Red blocks means that I've edited the configuration, but it has not been written to the transmitter yet. To write these parameters to the transmitter, I go up here and hit write to transmitter. Hit yes. Okay, and you'll see everything has been updated. Once all the fields go white, that means everything has been written to the transmitter. Now what I'm going to do on my demonstration unit is place a target on our probe. I'm going to go to real-time view. And you'll notice both in real-time view, I'm seeing a level measurement and a distance measurement. Also, you'll see that the image has also updated to show my level as well. And that's as simple as it is. There is no actual calibration of a TDR, there's simply configuration. Now, if you wanted to save this configuration file, all you have to do is go to File and Save. I will save this file as Impulse Test. Save this to my desktop. And we're good to go. Now, if you have multiple units, or if you would ever upgrade your unit and you need to pull that configuration file in, you can go to File, Open the configuration file, set your near zone and lost echo conditions, and if these values were different, all the blocks would show up as red, and you could simply hit write to transmitter once you load that file. And that's all there is to it. We've hoped you enjoyed this tutorial. Thanks for watching.